We've previously discussed tools for evaluating the quality of regression models, including quantitative metrics for measuring the errors from our models. In this video, we'll discuss a very important theme in predictive modeling applications that relates to the use and interpretation of these metrics. This idea is known as overfitting. The key idea motivating overfitting is that using the same data to both build and evaluate a model can be misleading in predictive modeling applications. Why? Let's develop this idea conceptually. Suppose that we're trying to develop a model to identify cat pictures from non-cat pictures, and we develop the model described on the right, based on the picture shown here. Cats have uneven black and gray stripes. They have tails that are 1 foot long. They have 2 ears that are white in the middle and tan on the perimeter, 8 left and 12 right whiskers, yellow-green eyes. They're lying down. Is our model a good one? Will it do a good job of identifying cat pictures? We may have the feeling that our model is overly specific. It is pretty detailed after all. We should ask ourselves what our model evaluation tools would tell us. If we apply our model to our available data, which is this cat picture shown, to compute evaluation metrics that quantify error, we'll do great. We'll do great because we constructed the model from this data. This is the idea behind overfitting. Overfitting occurs when we build a model that picks up too much on features that just happen by chance. Another way to put it is that the model effectively memorizes very detailed features of the data used to build it. In our cat model, the parts highlighted in orange are likely these chance features that happen to be present on this cat, but not universal to cats in general. So, this model has done a great job of predicting this one cat, but it will fail miserably when predicting other cats in other pictures. That is, this model does not generalize to new data well at all. It looks too closely at highly individual features of this cat. This abundance of detail certainly helps to explain how more of the pixels explain this particular cat, kind of like increasing R squared. But these additional features, which are analogous to additional predictors in a model, don't help make a good general model for cats. In regression tasks, perfect overfitting can happen when using linear regression models if the number of coefficients in the model is equal to the number of cases. In these cases, when we use our available data to compute R squared and mean squared error, we'll get perfect values of 1 and 0. We generally won't be in situations where we're at these extremes, but whenever we're using a lot of predictors, we should be concerned about building models that overfit our data. As we move through the course, we'll be vigilant about building models that are overfit. We'll develop ideas to do this in 2 ways. For one, we'll develop new tools for quantitatively evaluating the accuracy of models on new data. Also, as we explore new model building techniques, we'll see how features of these techniques can be tuned to protect against overfitting.